This video is about solving problems involving independent events. So in probability, two events are considered independent if the occurrence of one event does not affect the probability of the other event happening. So probability of A given B is equal to probability of A given not B, which is equal to probability of A. So the fact that B has happened or has not happened does not affect the probability of A happening afterwards. Now, according to the formula, probability of A intersect B is equal over probability of B is the same thing as probability of A given B, which we've now seen is also equal to probability of A. So if we take this over here, then that means probability of A intersect B is equal to probability of A times probability of B, which is only true if A and B are independent events. And this is called the AND rule for GCSE. So if it's probability of A and B happening, it's probability of A times probability of B for A and B, which are independent events. So these are two things that you need to remember for independent events. Okay, let's go through some questions. So two events A and B are independent. Probability of A is equal to a quarter. Probability of B is equal to a fifth. Find probability of A intersect B. So A is probability of A intersect B. Because they're independent, it's probability of A times probability of B, which is equal to a quarter times a fifth, which is 1 over 20. B, probability of A intersect not B is probability of A times probability of not B, which is equal to a quarter times probability of not B will be 1 take away a fifth, which is 4/5, which gives us a fifth. C, probability of not A intersect not B is probability of not A times probability of not B. Probability of not A is 1 take away a quarter, which is 3/4. And probability of not B is 1 take away a fifth, which is 4/5, which means we get 3/5 in total. So if we were to draw a Venn diagram for this, A there, B there, then A intersect B is 1 over 20. Probability of A and not B is a fifth, so that will be here. Not A intersect not B is 3/5, so 3/5 here. And here will be 1 take away a fifth, take away 1 over 20, take away 3/5, which is 3 over 20. Paul and Jill decide to play a board game. The probability that Paul wins the game is 0.25, and the probability that Jill wins is 0.3. They decide to play 3 games. Given that the results of successive games are independent, find the probability that A, Paul wins 3 games in a row. So first thing I need to do is draw a tree diagram. So although they've given us 2 options, there's actually 3. So Paul wins, so I'm just going to call that Paul P. Jill wins, which is G. And the other option is obviously they both draw. Probability of Paul winning is 0.25. The probability of Jill winning is 0.3. So the probability of drawing is 1 take away 0.3 take away 0.25, which is 0.45. Now each game is independent, so that means, and also the probability doesn't change, so it's just going to be the same thing on 0.25, 0.3, 0.45. I'm not going to draw the whole thing out, but it's just going to be the same. All the branches are going to be the same. So it's going to be 3 here, 3 things coming out of here, 3 things coming out of here. So probability that Paul wins 3 games. So probability of Paul is going to be probability of Paul times probability of Paul winning times probability of Paul winning again, which is 0.25 times 0.25 times 0.25, which gives, I get 1 over 64 in my calculator. All games are drawn, so that is probability of draw, draw, draw. There's one possible way of getting it. Probability of draw times probability of draw times probability of draw, which is 0.45 times 0.45 times 0.45, which is equal to 729 over 8,000. So Jill wins 2 games and Paul wins 1 game. So it's probability of G, G, P. So there's 3 different combinations. Probability that Jill wins first, then P, then G, plus probability of P, G, and G. So there's 3 different ways you can get that combination. Now each one ends up being 0.3 times 0.3 times Paul, which is 0.25. But there's 3 different combinations, we have to times it by 3. And when we put this into our calculator, we get 27 over 400. Last one, each player wins just 1 game each. So that means we need to think about Jill winning, Paul winning, and then a draw. Now the different ways to get this is GDP plus probability DGP plus probability DPG plus probability of PGD plus probability of PDG. So there's 6 different combinations. So it'll be 6 times the probability of one of them happening is G is 0.3 times Paul, which is 0.25 times drawing, which is 0.45, times by 6, because all the probabilities are the same. It's just in a different order. When you put that into your calculator, you get 81 over 400. Next question. The events A and B are such that probability of A is equal to a third, probability of B is equal to a quarter, probability of A union B is equal to a half. Show that A and B are independent. So if we use the addition formula, probability of A intersect B will be equal to probability of A plus probability of B minus probability of A union B, which is equal to a third plus a quarter minus a half, which is equal to 1 over 12. Now we work out probability of A times probability of B, which is equal to a third times a quarter, which is equal to 1 over 12. Since probability of A intersect B is equal to probability of A times probability of B, which is equal to 1 over 12, A and B are independent. So if you can show that this works out, this formula works out, probability of A intersect B is equal to probability of A times probability of B, then they're both independent. So let's represent these probabilities in a Venn diagram. A and B, so we just worked out this is 1 over 12. Probability of A is a third, take away 12, which is 3 over 12, which is a quarter. Probability of just B will be a quarter, take away 1 over 12, which is 2 over 12, which is a sixth. If you add this all up and take away from, we know the union is equal to half, which means the outside part must be equal to half as well. See, probability of A given not B is probability of A intersect not B over probability of not B. A intersect not B is a quarter, and probability of not B is 3/4, because probability of B is a quarter, which means you end up getting a third. Okay, next question. Given that P of A is equal to 0.42, probability of B is equal to 0.37, and probability of A intersect B is equal to 0.12. Find probability of A union B. So probability of A union B is probability of A plus probability of B minus probability of A intersect B from the addition formulae, which is equal to 0.42 plus 0.37 take away 0.12, which is equal to 0.67. So if I were to draw a Venn diagram out, A and B, and this is, the intersect is 0.12. 0.42 take away 0.12 is 0.3, so this must be 0.3. Probability of B is 0.37, so just B would be 0.37 take away 0.12, which is 0.25. We've just worked out that the union is 0.67, so 1 take away 0.67 will give us the outside bit, which is 0.33. Okay, part B. Probability of A given not B is probability of A intersect not B over probability of not B. Now, probability of A intersect not B is 0.3, and probability of not B is 0.63, because it's 1 take away 0.37, which means we end up with 10 over 21. The event C has probability of C is equal to 0.3. The events B and C are mutually exclusive, and the events A and C are independent. Find probability of A intersect C. Now, probability of A intersect C, because A and C are independent, is probability of A times probability of C, which is 0.42 times 0.3, which is equal to 0.126. Draw a Venn diagram to illustrate events A, B, C, given the probabilities for each region. So now we could draw a new one, because we've got C involved now. Now we know A and C are independent, but B and C are mutually exclusive. So that means B and C will not overlap, because B and C are mutually exclusive. So let's call this one B, let's call this one C. Then A will have overlap with both A. So we know A intersects C is 0.126. 0.126. We know A intersect B is 0.12, because we worked that one out already, and A and B are independent. Oh no, we were given that, sorry. We were given that A intersect B is 0.12. Okay, so what we do to work out just C will be 0.3 take away 0.126, which is 0.174, because the probability of C has to add up to 0.3. Okay, probability of A is 0.42. So to find just A, you have to do 0.42, take away 0.126, take away 0.12, which means we end up with 0.174 here. Probability of B is 0.37. So if we do 0.37 take away 0.12, you end up with 0.25. To find the outside, you have to do 1 take away all these probabilities, all these 5 probabilities, which means I end up with 0.156 here. So 1 take away 0.174, take away 0.126, take away 0.174, take away 0.12, take away 0.25. Last part is E. Probability of not A union C not. Okay. So let's highlight first. So not A union C. Not A means everything that's not A. So it'll be this part, and the outside part, because that's everything that's not A. Union C. C means everything that's C. So it's that part. So all we need to do to work out the answer is, because it's A union C not, it's everything that remains unshaded. So it's equal to unshaded region, because what we shaded in at the moment is A union C. So we want the complement of that, which is what's not shaded in. So it's the same thing as 0.174 plus 0.12, which is equal to 0.294. Okay, next question. 3 events A, B, and C are such that probability of A is equal to 0.4, probability of B is equal to 0.7, probability of C is equal to 0.4, and probability of A intersect B is equal to 0.3. Given that A and C are mutually exclusive and that B and C are independent, find probability of B intersect C. So because B and C are independent, it's the same thing as probability of B times probability of C, which is equal to 0.7 times 0.4, which is equal to 0.28. Probability of B given C, and the condition formula of condition probability formula says it's B intersects C over probability of C. We've just worked out probability of B intersect C, which is 0.28, over probability of C is 0.4, which is equal to 0.7. C is equal to probability of A given not B, which is equal to probability of A intersect not B over probability of not B. At this point, it might be useful to draw a Venn diagram. So let's draw it out. So A and C are mutually exclusive, so they won't have any overlap. So A and C. And we have A intersect B, and we know that B and C are independent, so B will intersect with both. So A intersect B is 0.3, so we know that's 0.3. And we know B intersect C is 0.28. 0.28. Okay, probability of, let me just write this clearly. Probability of A is 0.4, so this must be 0.1. Probability of C is 0.4, so this must be 0.12. Probability of B is 0.7, so we've already got 0.58, so this must be 0.12. We add all these numbers together, we end up getting 0.92, so the outside must be 0.08. So probability of A given not B is probability of A intersect not B over probability of not B. So A intersect not B is 0.1, and probability of not B is 0.3, which is equal to a third. D is probability of B intersect C given not A, which is equal to probability, if I use the conditional probability formula, B intersect C intersect not A over probability of not A. So B intersect C and not A is just 0.28, because every part that's B intersect C is also not A. Over probability of not A is 0.6. When simplified, that becomes 7 over 15. John and Kaylee play darts in the same team. The events J and K are defined as follows. J is the event that John wins his match. K is the event that Kaylee wins her match. P of J is equal to 0.6, probability of K is equal to 0.7, and probability of J union K is equal to 0.8. Find the probability that both John and Kaylee win their matches. So that means J intersect K. Now we can use the addition formula, which is probability of J plus probability of K minus probability of J union K. 0.6 plus 0.7 minus 0.8, which is equal to 0.5. So if I want to draw a Venn diagram now, So we know the middle is 0.5. J will then be just J winning is 0.1. K winning will be 0.2, and the outside part must be 0.2. B. John wins his match given that Kaylee loses her match. So that means probability J given K loses, so K dash. Because K, remember, means K wins. So it's the same thing as probability of J intersect not K over probability of not K. J intersect not K is 0.1. Probability of not K is 0.3, which is equal to a third. Kaylee wins her match given that John wins his. Is probability Kaylee given J, okay, given J, which is probability of K intersect J over probability of J, which is 0.5 over 0.6, which is 5 over 6. Determine whether the events J and K are statistically independent. You must show all you're working out. D. So probability of J intersect K we've already worked out is 0.5. Probability of J times probability of K is 0.6 times 0.7, which is equal to 0.42. Now, since probability of J intersect K is not equal to probability of J times probability of K, therefore J and K are not independent. Two events A and B are such that probability of A is equal to 0.4, probability of A intersect B is equal to 0.12. If A and B are independent, find probability of B. So because they're independent, probability of A times probability of B is equal to probability of A intersect B, which implies 0.4 times probability of B is equal to 0.12, which means probability of B is equal to 0.12 over 0.4, which is equal to 0.3. B, find probability of not A intersect not B. Lots of ways of doing this, but we're just gonna, because A and B are independent, and not A and not B are also independent. So it'll be 0.6 times probability of not B is 0.7, which is equal to 0.42. A third event, P of C is equal to 0.4. Given that A and C are mutually exclusive, and probability of B intersect C is 0.1, draw a Venn diagram to illustrate this. So A and C are mutually exclusive, so they're separate from each other. A and C. B intersects with both because A intersect B and B intersect C are not equal to 0. So we know A intersect B is 0.12, and we know B intersect C is equal to 0.1. Probability of A is 0.4, so this must be 0.28. Probability of C is 0.4, so this must be 0.3. Probability of B is 0.3, so this must be 0.08. If you add all these numbers together and take away from 1, you get the outside bit, which is 0.12. Part D. Part 1. Probability of B given C is equal to probability of B intersect C over probability of C, which is equal to 0.1 over 0.4, which is equal to 0.25. Part 2 is probability of A intersect not B union C. Okay, so let's look at this. First, not B union C is everything that's not B. So that one, not B is here. All those are not B. Union C means everything that's C as well. So it's those three numbers. Okay, out of all those things, okay, which one intersects with A? So the only one that intersects with A is actually this one. So that means the answer would be just, so this one is A. So if I actually want to do it differently, so which will intersect with A, so that the only A's are this one and this one. Which are the parts that are both blue and green? Is just 0.28, so the answer will be 0.28. Okay, last question. A survey of reading habits of some students revealed that on a regular basis, 25% read quality newspaper, 45% read tabloid newspapers, and 40% do not read newspapers at all. Find the proportion of students who read both quality and tabloid newspapers. So we've got quality and tabloid. So quality and tabloid. 40% read neither, so 0.4 on the outside. So that means the union of quality and tabloid will be equal to 1 take with 0.4, which is equal to 0.6. So if I want to work out the intersect now, it's equal to probability of Q plus probability of T minus the union, which is equal to 0.45 plus 0.25 minus 0.6, which is equal to 0.1. Part B, and a space in page 13, draw a Venn diagram. So we started the Venn diagram already. So 0.25% read quality, so that must mean that part is 15%, which is 0.15. Tabloid is 45%, so this must be 0.35. Okay, and C, a student is selected at random. Given that this student reads newspapers on a regular basis, find the probability that the student only reads quality newspapers. So probability only reads quality given reads newspaper. So only reads quality is 0.15 over reads newspaper altogether, which is 0.6, which is equal to 0.25.